Hey everybody, this is Ryan Swanstrom and welcome to Data Science News for the week of April 29th, 2019. What is this, you may ask? Well, recently I found some articles on the internet that I wanted to share with everybody, so I decided to make a little video about it. If you find this video fun or helpful, please let me know and maybe I'll continue to make these videos. Anyhow, this is what I have to share today. I have 3 articles from the Data Science 101 blog. That's the blog that I run that I would like to pinpoint and share. And then I have 7 other articles that I found elsewhere on the internet that I thought were really good and I wanted to share with everybody out there who's listening. So with that, let's jump right into it. The first one we have here, I'm going to shrink myself down just a little bit, get myself out of the way. Anyhow, the first one we have here is Go language for data science. This is something that's come up a number of times over the last couple of years for me. And the question is, do data scientists use the Go programming language for data science? And I decided to start doing a little bit of research on this. So the last few weeks I've been spending time digging into and trying to figure out what packages are available and what support and help is there for Go programming language and data science. And this article is sort of my findings and what I determined, and I'll spill the answer for you here. Realistically, the data science community has not really adopted the Go programming language, but if you are in an environment where the Go language is used and you've solidified what you know your algorithm you're going to use is, it's maybe not a bad idea to use the Go programming language to rewrite your algorithms into Golang. And I think you get a performance increase from that, and it'll more easily integrate with the architecture of your overall organization. But Golang is probably not a great choice for exploratory analysis. Anyhow, if you want to know more about that, check out the article. I'll provide links for all the articles that I talk about here. The next one in the list is, I'm just going to go across my tabs here. The next one in the list is Azure Updates. I'm a big fan of Microsoft Azure and the cloud platform they provide for data science. Occasionally people ask me, how do I know what has been added to Azure lately? Because Microsoft is constantly adding new stuff there. And I just decided to make a really quick video to show you how do you actually find those updates, and they provide a nice sort of log of every day what was updated and how does that change affect you or not. That's what's there, so go watch that video if you're interested. The next one is, I recently discovered this just this week, but there's a wonderful YouTube channel called 2-Minute Papers, and what the channel is a person who finds interesting academic articles, academic papers in the machine learning and artificial intelligence, world, and the person turns those into entertaining short 2 to 3 minute videos talking about what's the high level concept of this article. So it's a great way to quickly find out what's going on in the latest research, and if you're interested, there are links to the articles that you can go download and read and really dig into what's in that article. Anyhow, the video I posted is about how can you change 1 pixel in an image and fool a neural network into thinking it's something else. So example, the picture you can see there is a horse. Can you change 1 pixel in that image and a neural network might believe it's an airplane or something like that. That's the article. Now let's jump into the 7 articles that I found elsewhere on the internet. KD Nuggets. This is a great website if you want to keep yourself up with the latest information on data science. It's been around for a long time. They organize a couple of conferences. Always good information on KD Nuggets. But I decided to highlight this one article because it's a large Q&A for aspiring data scientists. How do you get into the field of data science? And a couple of things that it covers is, what are some great courses? What are the skills you need? What are the books that you would want to read if you're interested in getting into data science? And even at the end, it includes a list of a number of people on data science that provide wonderful content to keep you on the latest edge of data science. Let's jump into the next one here. Uber. Uber recently submitted Hoodie. Hoodie is one of their open source software systems that they recently submitted it to the Apache Software Foundation. For a high-level description of what Hoodie is, it's spelled H-U-D-I, but it's pronounced Hoodie, like the sweatshirt I've got on, a hoodie. But it is a real-time stream processing system for big data. And they submitted it to the Apache Foundation because they thought this was a good enough piece of software that they want it to be run under the Apache umbrella and last longer and have better support than what Uber themselves could provide. So Uber's trying to, contribute back to the larger data science world. Interesting project. Go have a look if you're interested in doing some real-time or near real-time processing with some big data. The next one on the list comes from MLWiz, and I really like this one. It provides 3 visualization techniques, and the 3 visualization techniques are not the typical ones that people would use. It doesn't include pie charts and bar graphs. It includes a couple of other not so standard graphs that you may want to use if you're interested in finding a little bit of extra insights in your projects. I wanted to quickly run through to give you an example of them. The first one on the list is categorical correlations. And what those look like, it is how do you look at the features that you have in your data set that you're trying to model, and how are they correlated with each other. So it matches the features on one end with the features on the other, and then it gives you a large grid, darker the red, telling you the stronger the correlation between those features you have in your data set. So that's called a categorical correlation graph. Kind of interesting, and nice thing about this article is it includes Python code to create all of these graphs using the Seaborn visualization library. There's another one of those graphs. The next ones are pair plots, and these provide much of the same high level concept. You want to compare features against each other to see how they move or how they progress and how they're related. And so you can look at this graph. It compares your features and it plots them pairwise against each other. And that's why it's called a pair plot. And nice thing it does, you can look at a number of your features all in one graph, and you don't have to plot each one of those individually. So that's a pair plot. Kind of neat, really helpful. The next one here is called a swarm plot, and I honestly have never used one of these before. I hadn't seen them, hadn't heard of them, so I found this one really neat. Looks similar to a combination between a bar graph going across mixed with a scatter plot, and that's kind of what it is. And you can kind of look at the graph and kind of see what it's showing you and how those values move across as the wages increase. But those are the 3 graphs. If you're interested in doing some visualization to pull out a little bit more insight, have a look at those 3. The next article on the list is the difference between AI and machine learning. This is a wonderful article if you are new to the field, or if you've even been in the field and you're not quite sure what's the difference between these two. Is a good article for you to look up. From a high-level summary, AI is sort of a larger field than machine learning. Machine learning would be a subset of artificial intelligence. Artificial intelligence is interested in, making smart decisions. And machine learning is interested really in the same thing, but it's more specifically interested in making those smart decisions based off of input data. So one of the ways I like to think of it is machine learning always requires input data to work. Artificial intelligence does not always require input data to work. There's a little more to it than that. So if you want to know, go dig into that article and it'll help you out a little bit with that. Next up on the list, I picked this one out just because I have a long background in software engineering, and I found this article interesting. So it's titled Software Development Best Practices in a Deep Learning Environment. And here's where the problems come in, and here's why this article is written, because a lot of people that do deep learning are data scientists, and they don't necessarily have the training and the experience in the background in the world of software engineering. So things like automated testing and deployment and continuous integration aren't always something they've used or experienced or just had to deal with in the past. And it's not that it's bad, it's just that's not something they've had to do. And so this article talks about what are some tips and tricks for you to make this go a little bit better, and how can your organization increase the amount of software engineering when you're using deep learning. And one of the tips sort of at the end is use continuous integration and Docker containers. But it's got a lot of good stuff in that if your organization uses deep learning and you're deploying it out in production, this is probably a really good article to dig into. Next on the list, this was a fun one. This was good. It comes from the Simply Statistics blog, which is run by a couple of professors at Johns Hopkins University. This article in particular was written by Roger Peng, and I got to grab a drink of water before I continue on this one. All right. This is what this one talks about. I want to scroll down to the graph so that we can look at this, because I think the graph really sums it up. Let me move over a little bit so that we can see the full graph in here. But here's what it talks about. When you do a data science project, it's maybe not a great idea to start with your initial question and then just try to optimize that question as much as you can. Because if you look at the graph, what you'll see is you'll optimize it, and you can optimize it a lot, and you can go really high up on that graph. But the problem is you may not actually reach your goal because you're optimizing the wrong question. And what this article argues is it's maybe a better idea to spend a little more time exploring and trying to refine and come up with the best question or a better question that you could be asking, and then try to optimize that, because it's easier to move across the bottom, move horizontally at first, rather than once you get up to the top. Anyhow, it's a great article. It's a wonderful thought to consider, and how do you do that within your organization, and it was a little eye-opening for me. So I hope you like that one. The last one I saved the best for last. But this one digs deep into, if you are big into computer science and mathematics theory, here's a wonderful paper that I just discovered this week that I thought was really neat. There's a couple of mathematicians, Harvey and Vanderhoeven. I hope I'm pronouncing their names correctly, but they came up with a way to multiply n-digit integers in big O of n log n time, which is the fastest way we know of to multiply integers. One interesting thought on that is they proved that you could multiply integers in n log n time. They did not prove that that was the fastest way possible. So it is possible that we could even find a faster algorithm to multiply integers, but that's what this one proves here. For a little background on this, when you were in grade school or high school and you were trying to learn how to multiply integers, you typically put integers one above the other, and then you multiplied all the numbers in the bottom times all the numbers in the top, and you added them up. So if you had n-digit integers, that took big O of n squared. So if you had a 3-digit number that you were trying to multiply by another 3-digit number, you multiplied 3 times 3 multiplications, because you multiplied all the numbers on the bottom times all the numbers on the top. I guess it would be all the integers on the bottom times all the integers on the top. This is important because there's a number of problems in mathematics and computer science that rely on computations, and one of those is large prime numbers and finding them and determining whether a large number is prime or not, and that's important in computer security and cryptography. But there's other ones like determining the digits of pi, way out there, how many are there. But for a quick example of if you have 30-digit numbers, you're trying to multiply two 30-digit numbers, it would take approximately 900 operations, multiplication operations to do those the way we learned in school. But with the technique that Harvey and van der Hoeven came up with, it would only take roughly 100 multiplication operations to do that. So that's a significant difference there, and it's a whole lot quicker. I do remember back in grad school learning about the Karatsuba method, which allowed you to multiply numbers in big O of n to the 1.58 time. So that was faster than n squared, but still not quite as fast as n log n time. But there's a lot there. If computer science and mathematics theory is your thing, this is the article that you need to go into and read. It's kind of a big deal in that field and that world. But that sums up the news for the week. I hope you enjoyed this, and once again, if you liked it, let me know, and maybe I'll keep doing this. All right, thanks. Have a great week.